Hi, this is Mrs. Miner, and this is going to be how you do your notes for covalent bonding. So we are going to work on predicting the types of bonds that you can make from different elements and make sure that you have out your periodic table. So covalent bonds, we call them molecules, which is different than ionic bonds. We call those compounds. So molecules is going to be the word we use for the next month or so. These are only made of nonmetals, so you're going to see a lot of the same elements pop up over and over and over again, just because there's so many fewer nonmetals than there are metals. In ionic bonding, electrons are transferred from one atom to another, from the positive or from the metal to the nonmetal, the cation to the anion. Here, there's not going to be any ions at all. These are going to share electrons until they get 8 of them, and it's going to be very much like in kindergarten when everybody had to share Legos in order to build one big building. There are going to be weak attractions between the molecules, and what that means is that those molecules don't stick together very well. So it doesn't take a lot of heat or a lot of energy to split them apart. So we're going to have very low melting and boiling points. If you think about sugar, sugar is a great example of a covalent bond. All the time people are melting sugar to make candy, to make sculptures, and it's that low melting point that lets them do that. These are also going to be insulators. So plastic is a great example of something that has a covalent bond. And so these type of bonds are not going to be able to transfer heat like those ionic bonds could do when they were melted or aqueous. So at no point can these guys conduct electricity. Most of the time they're going to make gases at room temperature when you have a covalent bond. But every so often you will get what we call a soft solid, and those are solids that don't hold their shape very well. Again, like plastic or like Play-Doh, things like that. Now, one of the things that you can do when you make molecules with covalent bonds is you can actually put 2 of the same element together, and we call those diatomic molecules. So diatomic molecule is a molecule made of 2 atoms of the same element. So here you've got a nitrogen atom and a nitrogen atom, and they're bonded together. So the key is they have to be the same element in order for this to work. So on this side, here's oxygen, and they're bonded together. Okay? Whenever this happens, they're going to end up being gases at room temperature. There are 7 elements that can do this: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And you'll notice the little 2 back here. And that's because you have to have 2 atoms of that element. So you'll never just write hydrogen by itself. There'll always be a little 2 back here when it's by itself. Now if it's in a compound or a molecule, you're going to follow your bonding rules. Okay? Now there's 2 ways to remember these guys. The first one is called Brinkelhoff. And so if you arrange your element symbols like this, it spells out the word Brinkelhoff, and sometimes they're called the Brinkelhoff family. So the bromine, iodine, chlorine, hydrogen, oxygen, fluorine. The other way is the way that I was taught, and it's called use the 7s. And so this one is a little weird. If you find element number 7 on your periodic table, which is nitrogen, and then you make a 7, so that's going to be nitrogen, oxygen, fluorine, chlorine, bromine, iodine, so most of them. And then you have to add in hydrogen, because hydrogen is never where he's supposed to be. All right, naming rules for covalent molecules. These are going to be pretty straightforward. You always list the first element in the formula, and you use its entire name. So if your first element is oxygen, you say oxygen. If it's chlorine, you say chlorine. Okay? Then you list the second element in the formula, and you just change the ending to IDE. So if your second element is sulfur, then you say sulfide. So very much like ionic bonding so far. The difference is because you're going to have a lot of the same compounds or similar compounds with the same elements in them, you're going to see different subscripts or different numbers of elements down at the bottom. So we tell people how many there are using prefixes. So prefixes are going to get stuck on the front of the word. There's 2 exceptions to this. The first one is you never ever use mono for the first element. And the reason is if we used mono for the first element, 90% of them would start with mono. If your most of your prefixes are going to end in A, so if you have an A and then an element that starts with O, like oxygen, it sounds weird to have the A and the O together. So we drop the A. Same thing if you have an O prefix and an O vowel at the front. So this is really going to only be for oxygen. You drop the O off the prefix. So your prefixes, they're going to sound a lot like geometry. 1 is mono, 2 is di, 3 is tri, like tricycle or triangle, 4 is tetra, like the game Tetris. All the blocks are made of 4 blocks. 5 is penta, like pentagon. 6 is hexa. 7 hepta. 8 octa. 9 nona. And 10 is deca, just like the club here at school. So 1 is mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So when you name these, so if we start off with CCl4, your first element is carbon, your second element is chlorine. You only have one carbon, the prefix for that is mono, but we never use mono at the front. And then you have 4 chlorines. So you would put tetra prefix in front of your chloride. So carbon, tetra is the 4, and then chloride is your element. As2O3, As is arsenic, and there's 2 of them, so that's di-arsenic. 3 oxygens would be trioxide. So di-arsenic, trioxide. CO, you only have one C, and that prefix is mono. We never ever use mono at the front of the first one. And then your second element is oxygen, and there's only one of those. We do use mono on the second element, so this would be carbon monoxide. N2O, 2 N's is dinitrogen, and 1 O, again, is monoxide. Notice that there's not 2 O's here. We dropped the O from the mono and kept the O from the oxide. H2O, would you call that dihydrogen monoxide? No, we call it water. And in fact, there are 2 formulas that only get one name with them. Water is one of them, and ammonia is the other, NH3, and you're expected to remember these 2. So water, H2O, and ammonia, NH3. When you do formulas, you're just going to work backwards. No prefix means 1. Prefix of 5, or penta means 5, so this would be PCl5. Disulfur is 2 sulfurs. Trioxide is 3 oxygens, so S2O3. No prefix means 1, so 1 oxygen, di is 2 fluorines, OF2. Dinitrogen pentoxide, 2 nitrogens, 5 oxygens, N2O5. And then do you remember this guy? Ammonia is one you've got to memorize, and that's going to be NH3. So now you're at the end. You can either go back and listen again, or you can go ahead and make your summary. You can listen to this video as many times as you want, or for as many parts as you want.